In this lecture video, we'll take a look at a sample class model as illustrated on this slide. So this figure shows us a simple class model of a workstation window management system. So this model is actually simplified. A real model would require a number of pages, but here we illustrate only how much that can fit in this diagram. So the class window defines common parameters. These are the parameters, that is x1, y1, x2, y2, and these are the methods or operations, I must say, that are common to all the descendant classes. So they include a rectangular boundary. A window includes a rectangular boundary which is defined by x1, y1 and x2, y2, and operations to display, undisplay a window, how to raise a window to the top so that it's brought to the foreground, and how to lower it to the background. Send it to the background or lower it to the bottom if there is an entire set of windows. So this is the root class or the parent class of all the descendants which follow here. A canvas is one of the direct or immediate subclass of window. So a canvas is just a region for drawing graphics. So it inherits the window boundary from the window, this one, and adds the dimensions of the underlying canvas region, which is defined by cx1, cy1, cx2, and cy2. So this is the main window. Within that window, you can have a smaller canvas, and the dimensions of that canvas are given here. But canvas is present on the window, so it requires attributes here which it inherits from the window class. A canvas contains a set of elements shown by the association to class shape. So a one window or one canvas contains a set of elements. All shapes have color and line width. Shapes could be lines, ellipses, that is closed shapes could be ellipses or polygons, each with their own parameters. A polygon, if you see, consists of a list of vertices. Ellipses and polygons are both close-shaped, which will have therefore a fill color and a fill pattern. Lines are one-dimensional and cannot be filled. Canvas windows have operations to add and delete elements. So this is how the hierarchy looks from window to canvas. Canvas has association with the shape class. Shape class has two immediate subclasses, that is line and shape, line and closed shape, where closed shape again has two immediate subclasses, that is polygon and ellipse, where polygon has an association with a point class, because a polygon will have n number of ordered vertices. You can see the ordered keyword here because it's a collection of or a set of ordered elements. So polygon will have an association with a point where every point on the screen is represented using one x and one y point on the coordinate system. So when you have to draw a polygon, you'll need multiple vertices, and you join the vertices using lines. So the vertices are definitely ordered, and that this shows the association between the polygon class and the point class. So if I take the polygon class, its ancestors include closed shape, shape, and closed shape and shape. Remember that the polygon class does not have window as its direct ancestor because its association and the generalization ends here. This is just action. So understand the difference between that. If you take the line class, it has only one. It has one level of hierarchy, one level up. That is shape. Now, shape is not a subclass of canvas. Shape is a class associated with the canvas class. So please understand the difference between that by taking a look at the UML notations. So let's continue. If you consider the text window, it's a class which is a subclass of scrolling window. So the scrolling window has two-dimensional scrolling offsets within the window specified by X offset and Y offset. So offset from the point to show the scrolling. So it also has an operation scroll to change the scroll value. A text window here, which is a subclass, immediate subclass of scrolling window class, has a string and has operations to insert and delete characters. Scrolling canvas is another direct subclass of scrolling window. It's a special kind of canvas that supports scrolling. So if you take a look at scrolling canvas, it inherits both from canvas as well as scrolling window, because this is a special type of canvas that can be scrolled. Otherwise, what you have here is a fixed kind of canvas. Maybe if you have a canvas that can be scrolled, you can see this is kind of a complex generalization, not a simple generalization. Simple generalization is something like this, where if you take any subclass, it has only one immediate parent. But if you look at this generalization, you can see scrolling has two parents. This is kind of a complex generalization. Let's look at the panel class. So the panel contains a set of panel items. So you can see panel item is a direct subclass, each which is identified by a unique item name. So every panel is qualified by an item name. So you can see the qualifier here. Okay, so this is the task of the qualifier to be identified uniquely as shown in the qualified association. Now, each panel item belongs to a single panel. A panel item is predefined icon with which a user can interact with with the screen. So your screen may have multiple icons, and each of them is a panel item. So panel items come in three kinds as shown here. They could be buttons, they could be choice items, and they could be text items. A button is a string that appears on the screen. A button can be pushed by the user and hence has the attribute, it's a string type and has the attribute depressed. A choice item here allows the user to select one of the predefined choices, each of which is a choice entry containing a string. So you can see that association here. And based on the selection, a value would be returned if the entry is selected. There are two associations between choice item and choice entry. And one is a 0 to 1 association, and one is a 1 to many association, which allows you or defines a set of allowable choices. So you can also see that this association is labeled by the arrow subset. So this denotes that one association is a subset of the other association given by this arrow indication. When a panel item is selected by the user, it generates something called as an event. So here you can see panel item class is associated. It is not generalized, but it's associated with another class called as event. So, which is actually a signal that something has happened together with the action to be performed. All kinds of panel items will definitely have a notify event association, because when you click or when you select a panel item, which could be a button, choice, or text item, there is some event that is going to happen. Maybe it will open something up, maybe it will show you another subset, a nested menu, or something like that. So each panel item has a single event, but one event can also be shared among multiple panel items. Text items here have a second kind of event which is generated when a keyboard character is typed while the text item is selected. The association with the end name keyboard event shows this kind of interaction here. So you can see there is an association between text item and event action, and the association end name is called as keyboard event, because text items usually have the user to text in something from the keyboard, causing a keyboard event to occur. So this is a sample class model, and this also has comprises of concepts which were not covered earlier. So this is just for you to understand for illustration purposes only. This covers the concepts of generalization, inheritance. It also covers the form of complex generalization where one class can inherit from two parents. It shows associations, it shows ordering, it shows subsets of association, it shows qualified association and everything. So almost all the concepts that we have learned throughout this chapter have been covered. All the concepts have been covered or illustrated in this sample class model.